the dx. And plus c. These ones don't have plus c. These are all definite integrals, right? So we don't have to worry about plus c, at least. Okay. So, what integration witchcraft should I use to solve this problem? So I have decomposition and I have a u sub. You guys want to go out and then, or we can
take the log at the bottom.
take the log at the bottom. Yes. So it is the u sub, because the derivative of x cubed plus x is on top, and it's going to work out to be log. Great. So we're going to do u sub over here. Where's Angelo?
We don't know.
Carson, you had a point.
It's not that the stream is not doing too. Come on, man. We miss you. So we're using a basic u sub because the problem is so nice. So now we go and we have our limit. B goes to infinity. Integral. And we have du over u, which is the limit. B goes to infinity. And this is going to be ln u, so it's ln absolute x cubed plus x, calculated from 1 to b. Right? You remember that you have to go back to x variables so that you can use your limit b goes to infinity when we eventually get there. So now what we have? We have limit b goes to infinity of ln b cubed plus b minus ln of 1 cubed plus 1. So, what now? Okay.
You can't do L in infinity, can you?
Can we? Yeah, we can. And we know what it is. But do we all agree that this would be ln of b cubed plus b over 2?
Yes.
Yes, using the log compression, right? We have a log minus log, so we can combine everything in 1. Second log is 1 plus 1 is 2. And now we take a look at the graph of ln, and do we see that as x goes to infinity, we also see that y goes to infinity, right? So we say divergent. Divergent because the answer is infinity. So we just learned that the answer is 50-50. You guess divergent, convergent, 50-50. You can just guess. 50-50 chance to guess. So it's a good odds, right? Yeah, the entire next chapter is not chapter 10. It's going to be convergent or divergent, the entire chapter. So we'll do some probability, see how well that works.
Where did you get the over 2 from?
From here. Right? Log minus log is log, and you divide.
So, your answer is infinity divergent or just divergent?
Infinity means divergent. Right. These problems did not exist in a previous edition. I love this. I love this edition of the book. 29. From negative infinity to positive infinity, lock the door, tangent inverse of t squared divided by t squared plus 1 dt. Is this type 1 or type 2? Type 1. We can see infinities, right? So we're technically done with the lecture. Now let's go talk integration.
I'm surprised that he eats the bites instead of just the whole thing.
Like you said, negative infinity. No, negative infinity to the b.
I'm insulted you to make me eat it.
That hurts.
From negative b to b it? Now,
Can you have a limit in a limit?
now he's asking a right question. He said, can you have a limit within a limit? No. But I need to have a on the bottom and I need to have b on the top, right? And you can't have both worlds. Right?
That doesn't work.
It's the other one is convergent.
So let's just skip all the work. Right to the guess. Okay. So the bottom one limit over here has to be a, the top one has to be b. We can't have two limits in one. So what do? We split this into two integrals at, let's say, 0. If you like pain, you can split it at e squared, but 0 is kind of cool. So now what you're going to have? You're going to have a first integral. That's Calculus theorem. So you're going to have your first integral go from negative infinity to 0 of this, plus the second integral, exactly, 0 to infinity. And then one gets a for negative infinity, the other one gets limit b to infinity. Yeah. Nice, right? Then we have to figure out which integration we're going to do to deal with the middle, which should be obvious. Can anyone tell me the answer for the integration just by looking at it? Because it's obvious. Come on. No. No, I'm asking for the answer. I'm not asking for the method. Method should be obvious. Yes, tangent cubed over 3. Nice. Tangent inverse cubed over 3. Good. All right. No, I was asking for integration. All right, so let's go. Negative infinity to 0 of this mess. Plus 0 to infinity. Guys, you have to agree that this is an excellent conversation starter for next family meal you're going to have. You open with this problem.
You just dx'd.
I should have DT'd. There we go. It's DT'd now. In the next step, we get to plug the limits. So here's the limit a, lower limit, going to negative infinity. Integral a to 0. I gotta write this stuff again and again and again. Who picked this problem? Plus limit b goes to infinity, 0 to b. You should leave this casually on a dining room table or something.
You know, it's funny, my daughter, she like when I'm doing homework or whatever, if she looks at the computer, she looks at my notebook. She's like, oh, what is that? And I'm like, this is calculus. But I don't understand it. It's not even numbers. It's like letters and stuff.
Super mom.
Letters. She's like, where's the numbers?
There's a number. Look,
Yeah,
two.
not many though.
You gotta look for it, but
She's like, how do you have math and no numbers?
okay. So what now? We go home. So what's the integral? What are we using? Yeah, basic one. Which one? U sub. So if U is inverse tangent of t, then du is 1 over t squared plus 1 dt, which is exactly what we have. So these integrals collapse into limit a goes to negative infinity of integral of u squared du plus limit b goes to infinity u squared du. Limit a goes to negative infinity of u cubed over 3 plus limit b goes to infinity u cubed over 3. Now u is inverse tangent, so limit a goes to negative infinity of inverse tangent of u cubed plus limit b goes to infinity of tangent negative, sorry, these are not used, these are t's, cubed over 3. Now the first one was from from a to 0, and the second one is from 0 to b. There we go. Limit a goes to negative infinity of tangent inverse of 0 cubed over 3 minus tangent inverse of a cubed over 3 plus the limit b goes to infinity of tangent inverse b cubed over 3 minus tangent inverse 0 cubed over 3. All we have to do is to compute this, we're done. Now, do you remember the first day of your Calculus 2 course?
Yes.
Which graph did I draw the first day? The only graph that I drew the first day was... Let's find out. The only graph which I drew on day 1 was the inverse tangent graph, because. So if you flip your notes, somewhere in there, you are going to find the inverse tangent graph that is between negative pi over 2 and pi over 2 on the y-axis.
But you did it the other way. You did tangent. You didn't do inverse tangent.
Yeah, same.
No, it's not. That's a negative tangent.
So now, when you apply, first thing you see is that inverse tangent at 0 as x input has an output of 0. Therefore, all of these terms that have zeros die because they're at the origin. Inverse tangent of 0 is 0. Then 0 cubed divided by 3 is still 0. The next terms that you have to worry about is what is inverse tangent when x goes to negative infinity, which is this term here, right? Going to negative infinity. So this is the piece that it's going to negative infinity. And the answer is negative pi over 2. And then this negative in here is going to give us positive pi over 2. So this is further equal to positive pi over 2 because you have this negative and this negative here. Negative and negative is positive. So we have the first one to be that. And then we have plus. And now for this one over here, as you go to positive infinity, which is this side of the inverse tangent graph, that's going to send you to, in a y, right? It's another pi over 2, and the answer is pi. We say convergent to pi. So this means that the integral that we had converges to finite value, which is pi.
Can you start back over where you said wherever there's a 0, it goes to 0?
That's the part when, give me 1 second. Oh. So, inverse tangent of 0, you look at the graph, is 0. Because 0x gives 0y because it goes to 0, 0. So this term and this term are both going to 0 because they have inverse tangent of 0. Just like inverse sine of 0 is also 0. And inverse cosine of 0 is not. Yes?
All trig functions are convergent, aren't they?
What happened?
Aren't all trig functions technically convergent?
No. Nope. Nope, 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 nope. So we have these terms, they die, and then we use the sides of the graph to pick up the limits for the rest. So what are our sections that we have to review? Limits at infinity, infinite limits, and L'Hopital rule. Because some of these, when you integrate them, L'Hopital rule is going to be the Bernoulli's rule, but L'Hopital. Yes?
So you have negative in front of your inverse tan.
Right here.
Yeah, a to the third.
Because it's f of b minus f of a.
Right, over 3. And so you're saying all of that is equal to pi over 2.
Oh, I forgot to cube it and this. Yeah. No, this thingy in here is, yeah, you're right. Holy nightmare. Back to the drawing board. So this is negative pi over 2 cubed over 3 plus pi over 2 cubed over 3. There we go. So now this is positive because you have 3 negatives and a negative on the outside, so that's 4 negatives. So you have your pi cubed over 8 times 3, 24, plus pi cubed over 2 cubed is 8 times 3, 24, for a total of 2 pi over 3 over 24, which is pi over 3 over 12. Pi cubed over 12. Very good. So I was just testing all of you, and you all failed. Olga, very good.
Thank you. And I said convergence in the beginning, so.
plus 2. So converges to pi over 3 over 12. Pi cubed over 12. That's the answer.
So, it's convergent if it goes to like
A finite value,
and
yes.
it's divergent if it goes to like
Infinity or negative infinity. Yep. All right, so now I am 1 for 1, right? Let's see if I get the next one. Well, at least I knew it was convergent. I mean, integral 0 to 8 dx divided by the cube root of x. I posted the cupcake. I said I posted the cupcake.
Oh, you can see it. Where do you see it?
I just ate it for now.
Oh, shoot.
No, I said.
You have a good amount of follow. A little heart. You should tag me. Are you streaming?
No, there's a way.
Like we're not sounds.
Okay, it's still about 50.
My teacher literally goes, he's like, yeah, we should probably have a discussion after the next test.
That's too late. Yeah, we'll talk later. Two more songs.
What if I ace it?
You can.
Right?
So what's the verdict? Is this convergent or divergent, Olga?
I say it's divergent.
You say divergent? No? There's the asymptote, right? So this is type 2. And it's easy to see type 2 because the asymptote is at one of the limits. When asymptote is buried inside, you have to break your integral into two separate integrals. At that asymptote, use two limits, just like we did previous problem with infinities. Now, in this particular problem, your asymptote is at the edge, so only one integral. You are replacing the bottom. So limit a goes to 0. That's the problem. A to 8. And then this is x to the negative 1/3 dx. So now we have limit a goes to 0. And we have our integration plus 1. So x to the 2/3 divided by 2/3. Computed from a to 8. This is, forgot the limit, minus 1. Limit a goes to 0 of 3/2, 8 to 2/3 minus a to 2/3. Now, how much is 8 to 2/3? 4. Very good. You take the cube root first. Cube root of 8 is 2, and then you square it. It's 4. So this becomes limit a goes to 0 of 3/2 of 4 minus a to the 2/3. So when a goes to 0, that term dies, and we just learned that we can't guess every time, right? Previous one, you guessed it converges. It did converge. Now you guessed it diverges. It converged, which means we should be able to guess about half of the time, which is 50, which is less than 70, right? It's called probability. So you should miss half of the time. And yeah, so this one is convergent to 6. It's a vertical asymptote. Most of them diverge. Not this one.
Can you show how that would look on the graph of the cube root of x?
Sure. So 1 divided by x to the 1/3. 1/3 exponent is a cube root, and it looks pretty much like, right?
So then when it converges to 6, like what does that mean on the graph?
What it means is that you are going to, that's an amazing question, and thank you for asking. All right? It means that the area under the curve is 6. So, if I go and calculate this area, this is 1 unit, right? That's 7. And this is the height, is also 1 unit here. So, no, 1 unit is here. So this block of 4 squares is 1 square inch, meter, whatever, which means that every 4 squares are giving me a unit of 1. So 4 squares is 1 unit of area. I should have from 0 to 8, 24 squares under the curve. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 that I can see. And where are the other 6? All these little pieces, you cut them out and, you know, put them together like a jigsaw puzzle, and they will work out to be 6, right? Because you have, right, you have this cutout here, and you have this missing piece here, so you just fit that in there, and that's another one. And then you have this piece, and this piece, and this piece, right? So all together, they will add to area to be 6. And that's what we calculate. Now, physics is the energy, and so on. Then you use application. Great questions tonight. Yes?
Yes. So I understand that this has a finite
Area.
answer area because it has 0 and 8. So like there's, it's, you know, like a certain area. But like if.
But the area is leaking because over here, this red line will never touch the y-axis.
Yeah,
So the area is leaking on top and it goes to infinity, but it doesn't leak so much, right?
So it doesn't make a difference.
No, because it's very sluggish. Yes. Have you ever driven behind someone who's doing 5?
Yeah.
It's just knuckles. Oh, they have. Oh, there you go. Yes.
Can you use this to solve other discontinuities, or is this the only one?
That's the only one, because when you have a hole, we don't really care. We just plow. Right? We worry about asymptotic discontinuity. Those are the bad ones. when they don't converge. Like this one converged, so this is a good one, right? Like you wanna have this one. All right. Let's do one more problem and then take the break. When we come back, differential equations. Entire course in one. I am. All right, so how about you pick a problem from the list? Look how nice they are. They gave you 60 problems to practice. And they mixed them, you know, type 1, type 2, everything on a pile. Number 1 is not showing here. You can see 23 through 50. What's going on in 24? Oh, a being bigger than 0, so they give you a negative infinity here. They tell you that the top limit is a. So you get to pick any positive number. So you are solving integral across the parameter a. You're solving infinitely many problems in that one. Your answer will be in terms of a. That answer will be infinity. It diverges. If it's, let's say, 2a divided by 7, converges to whatever a you picked. So which problem should we look at? 23 to 50?
27.
27. Nice. Because it's easy to integrate, so that's why, you know. No. Also easy, so I'm not happy on that one. I'm trying to see if anyone is going to pick like a bad one. So you picked so far 27, 36. They might look bad, but they're joke.
41.
41.
It was on everyone's minds.
Just a secant tangent, just integral of secant tangent secant, basic integral. Like you don't even have to worry about u sub on that one.
Which one looks
hard? 34.
Hey, you picked the hardest one out there. There you go.
34 looks hard?
Yeah, they all look the same.
No, it's just a tangent of one over s. It's basic. Times 2. So it's a u sub. Okay. Can anyone pick out the bad one? So far, all the u subs. You picked all the u subs.
Can't really see from here.
Can't really see from right there.
Go to the next page.
How about, there's no next page.
Okay, what's your
Okay. Let me
58.
what's our e
control.
to the square root of x?
If I do control, oh no, control minus. They have this thingy here.
There's one that's e to the square root of x.
58.
58.
That looks like a partial fraction.
All right. So let's run through integration techniques. Remember what I said? You have all different integration techniques. The problem on the test just says integrate. Which method do we pick? Right? Just like derivatives, product rule, quotient, right? So now you have integration techniques. First one is u sub. Very good, right? Root x, you have 1 over 2 root x, so you need to fix that half and you got it. This one. U sub, right?
Hell yeah.
How about this one? U sub, exactly. X to the 4, x to the cube, the derivative on top, great. This one? U sub, we just did it, right? This one? U sub. This one? All U subs, exactly. Ah! By parts. How about this one?
That's a trig.
Hello, trig sub. There's a 30-minute problem, dragging that ln, limit for 5 pages, right? How do you integrate ln x?
Integration by parts.
Integration by parts, or you memorize the formula, right? ln x is not a basic integral. You use integration by parts to do it. However, you might sit down and memorize, right? X minus x ln x. How about this one? Very good. By parts.
Oh, okay.
E to the 2x minus 1.
That could be trig sub, right?
That's going to be trig sub, yeah.
That was in the homework.
It looks like it should be U sub, but it's not. That's a 2x. That's a single x right there. So that's the evil one. How about this
That
one?
was due?
I have no clue.
Oh.
I don't know, 56. I guess we rationalize and then we see what happens. 57 with the absolute value, we break that into two functions, so that's just the basic integrals. How about 58? Now 58 is tricky because 58 is either going to work. So we want to do this one, 58? All right, let's do 58. Guys, what we just did is a review for your next exam. Yeah, that was a review for your next exam. That's the only thing that your next exam consists of. You figure out what is the proper integration technique and just executing it.
Oh. I thought you said you figured out the proper technique.
It's just 58.
Yeah, your next exam is just 58. All right, so as you are looking at this problem, what are the possibilities to have here? So, what are the two possibilities when you see a polynomial in denominator? What are the two possibilities, two techniques of integration we learned that can be applied in that case? One is clearly decomposition, and the other one is we don't have x plus 2 on top, so no U sub. Yeah. You asked last time. No, partial fraction, we always said partial fractions. Okay, is this partial fraction decomposition?
Yes.
No. You can't factor this.
Well, you use long division and then you can, right? The ones that you can't factor, you just use long division.
You can divide this into one and...
Of course you can do that.
Oh, what the hell?
Numericals ax, ha, and then b plus.
Oh, man, maybe it's one of the
Yeah.
The
They
second
have it
one.
on there. That's
Third
number
one. It's the
3.
third one. Yeah.
But you have to have at least two factors for partial fraction decomposition to work. Complete the square. Use what?
I've said that.
He did say that.
Use what? Complete the square. Use. When you complete the square, what do you get to use?
You add and you subtract stuff.
That's to do to complete. But when you're done with completing the square, which integration technique?
Oh, type 2. No, type 1. I don't know. Just tell us, damn it.
Partial fractions, right?
Hello, trig sub. I know. We had this problem when we did trig sub, guys. Come on. We are going to trig sub now. I'm going to find the problem. There it is.
It doesn't look like that yet.
Yeah, but when you complete the square, it will.
It will look like that.
Yes, the problem 66. It's missing 1 6, but that's okay. So, when you have a trinomial in denominator, This is exam review again that I'm now doing. When you have a trinomial in denominator, if you can't factor it into two binomials to do partial fraction decomposition, then you get to do completing the square and its trig sum. That's the only two tricks that we have. Obviously, if you have x squared minus 2 on top, 2x minus 2 on top, it's u sub basic, right? But if you have this situation that you can do u sub, then if you are able to factor, you are using two linear with your a and b for partial fraction decomposition. If you can't factor, then you have to do the completing the square, and then you have your trig sum. So our problem now in over there is trig sum. Yes.
Okay, I'm just like something to clarify, I guess. For like the 4 cases for partial fraction decomposition, the third case is set up just like that.
Yes,
So,
but you can't have only one. For partial fraction decomposition to work, you have to have something else with this.
okay.
Because you are supposed to add the two and... right. Completing the square. We need to add and subtract 1. So to complete this square, let's do it in red. Let's do it in orange. X squared plus 2x plus 1 minus 1 plus 5. First 3. Square root of the first, sine of the second, square root of the third, everything squared. Plus 4. Break this into 2 integrals, do the limits and everything. So we're doing 3 steps in one. Limit a goes to negative infinity, integral a to 0, right? You can pick any number in between. And we have dx over x plus 1 squared plus 4. Plus limit b goes to positive infinity, 0 to infinity, dx over x plus 1 squared plus 4. Now please observe, this is supposed to be b, not infinity. There we go. Please observe that these two integrals are exactly the same. So you just need to integrate one and use the same antiderivative with both sets of values to plug in. So we do our trig sub now. Here's my theta. Guys, these are legs, right? Because it's a plus. So x plus 1 and the 4. And this one is the square root of x plus 1 squared plus 4. We work out the red. That's tangent theta is x plus 1 over 4.
Should 4 be 2?
4 should be 2. Thank you. 4 should be 2. I was just testing you all, and very good, very good. So x plus 1 is equal to 2 tangent theta, and dx is equal to 2, the derivative of tangent is secant squared theta d theta. Then we have our blue. That's going to start as a cosine theta as 2 divided by square root of x plus 1 squared plus 4. Then the entire square root is equal to 2 secant theta. And because I don't need the square root, I have to square both sides. So the x plus 1 squared plus 4, which is what I actually need, is for secant square theta. Now I'm just going to integrate and then plug stuff in later. So let's go orange, I guess. Integral of dx over x plus 1 squared plus 4 is, instead of dx, I have 2 secant square theta, d theta. And instead of this square root, I have 4 secant square theta. Beautiful. This is 1/2 integral d theta, which is just 1/2 theta. Now I have to change theta back into what we have, so we can use inverse tangent x plus 1 over 2. So 1/2 inverse tangent of x plus 1 over 2. So now we get to plug this into our limits and improper integrals and all of that stuff. So that's equal to the limit a goes to negative infinity of 1/2 tangent inverse x plus 1 over 2, and the limits are a to 0, plus limit b goes to infinity 1/2 tangent inverse of x plus 1, there goes your weekend, over 0 to b. You feel like, right? We can factor out this 1/2 in front of everything from both of these. And I have limit a goes to negative infinity of inverse tangent of 1/2 minus the inverse tangent of a plus 1 over 2. And then we have plus, and now we have the second one, which is limit b goes to infinity, plug in b, so that's tangent inverse of b plus 1 over 2 minus tangent inverse of 1/2 again. You have a positive and negative of these, so they cancel. The tangent inverse of 1/2. We don't care how much it is because it just cancels. Okay, now we use our handy dandy graph for inverse tangent. And let's try to do it correct this time. So I have this a is going to negative infinity. If a is going to negative infinity and you add 1 to negative infinity, you are still at negative infinity, right? And then you divide negative infinity by 2, you are still at negative infinity. So tangent of negative infinity is negative pi over 2 on this side, on the bottom, right? So the whole thing here is negative pi over 2. Why 2 negatives? One negative is already in the problem. That's the first negative. And then this answer here is negative pi over 2. So you get 2 negatives. And then we have plus from the problem. And then we have tangent of positive infinity, which is positive pi over 2. Well, this is equal to 1/2 pi over 2 plus pi over 2. which is pi over 2. Convergent on 58. All right, so now I want to do something. Integrate 1 divided by, I have no clue if this is going to work. It would be great if it did. 2x plus 5 plus 2x plus 5 from minus infinity to infinity. As your Wolfram, right? Did a little bit faster than us, right? But I got it. So you get to check your answers, right, in the software. And I think that they charge monthly to see the steps and all of the other stuff. But I think if you buy it on a tablet or a phone, it is one charge for the app forever.
It's one charge on the computer too.
Now it's one. It's no longer a monthly subscription. It used to be like $2-3 a month, and it was $5 for tablets. So if you buy it as an app, you pay once $5.
The whole year it was like
I mean, it's educational too. When I went to school, there was no YouTube. 2000. When I did this course in 2002, and YouTube is 2006. The only sources you have are tutors, professor, and library books.
Mine is the first one out. You don't have any here.
All right. Well, that's it. That's improper integrals. Did we learn any integration technique? No. Right? Did we review limits? Of course we have. We heavily worked on inverse tangent. More of inverse tangent coming up eventually. And please look into L'Hopital rule just in case, because you should have that creep in. Plus, guys, your entire chapter 10, which we are starting next week, is L'Hopital rule, like the entire chapter. Every single problem is a limit problem in chapter 10. 100% of them.
So as of right now, we are done. What's going to be on exam?
After the break. So we'll take a break now. When we come back from the break, we're going to do differential equations. One lecture, differential equations. And then after that, we are done with the material for the exam 2, which is covered by labs 2 and 3. We'll talk about the dates. And then next week, regardless which way you vote, we are starting chapter 10. We have chapters 10, 11, and 12 to go.
10, 11, and 12?
10, 11, and 12. Yep.
That's it.
Bye.